Okay, in this problem our assignment is to find Vs and the power supplied by the 10 volt source if that 3 amp source supplies 12 watts. Okay, so there's our task. And to start off, we know that this 3 amp source supplies 12 watts. If we go back and remember our passive sign convention, P is equal to VI, okay, and if the current's entering the plus and leaving the minus, that's a convention for power absorbed. Here we're told that the 3 amp source supplies 12 watts, so then that would tell us that the voltage across the 3 amp source is 4 volts with that polarity. It has to be that polarity because we're told it's supplying, so the current's got to be coming out of the plus. Okay. Now, we know the current flowing through this 4 ohm resistor, and from Ohm's law then we know that the voltage is 12 volts with that polarity. Okay. So now let's define a voltage Vx, and let's apply KVL around that loop. Okay, and if we do that, starting here, we'll have minus 4 starting here. So I have minus 4 plus 12 minus Vx equal to 0. So that tells me that Vx is equal to 8 volts. Okay, then by Ohm's law, that tells me that that current is 2 amps. Okay. Our next calculation then is the voltage across this resistor is 10 volts because it's in parallel. So the current flowing through the 5 ohm resistor is 2 amps in that direction. We have 3 amps entering from that resistor. So if we look, there's 3 entering, 2 leaving. So the current flowing that direction must be 3 amps. So now we can calculate the power supplied. And if we notice, the current is flowing down, it's entered the plus and leaving the minus. So if we take V and I, this will give us power absorbed. So 10 times 3 is 30 watts absorbed. So the power supplied then, so the 10 volt source supplies minus 30 watts. We still have to calculate Vs. Now let's define a voltage Vz, and let's use Kirchhoff's voltage law around this loop. Okay, if we do that, we'll have plus Vx plus 10 minus Vz equal to 0. So Vz is Vx plus 10, which is 18. And now we can apply KVL around that loop, and we would have to know the voltage here, and to calculate that we can apply Kirchhoff's current law at this node. For instance, we know Vz is 18, so the current flowing through that 6 ohm resistor is 3 amps in that direction. We know there's 3 amps leaving, 2 amps leaving, so that tells us that this current then is 3 plus 2 plus 3, or 8 amps. So we get 8 amps of current from Kirchhoff's current law being applied at that node. Then that tells us that the voltage across this resistor is 24 volts with that voltage by Ohm's law. So then applying KVL to this loop, Vs then is 24 plus 18, or 42 volts.